It is an annual tradition for me to make these way too early winter weather predictions, and I'm crazy enough to make it more detailed than in years past. So, what is going to be happening in the upcoming 2024 to 25 winter? Well, let's find out. As always with these long range forecasts, I do like to post this disclaimer because it is just intended to provide a general sense of what may happen in the upcoming months. It is not a this is for sure happening, nor is it an excuse to not be prepared for any significant weather events that may or may not come your way. So, on to why I do not really predict anything during the summer months. Larger scale oscillations are the basis of my wintertime predictions due to correlations between them. However, these correlations are weaker to non-existence between June and mid-October, making predictions harder than forecasting for winter. So, not really worth my time at that point. And also, on top of that, summer is not only warm more than any other season, it has also gone more in waves, especially like about 10 years ago. There was a quick wave where it jumped up to right around 3 degrees above the long term average and has pretty consistently stayed there. And that makes adjustments harder as well. So, onto our methodology for the upcoming forecast here. I do still use an analog year approach. However, I am not adjusting the analog years equally because of how far out this forecast is, and I am only using the ENSO index via the ONI. I'm not using any of the other oscillations because I want that to be closer to the actual main forecast date of October so that I can get more accurate numbers for what I'm expecting in the upcoming winter. The only one that I can firmly predict this far out is probably the Atlantic multi-decadal oscillation, which I expect it to be firmly in the positive phase again this coming winter. Though, if you told me make your prediction for the PDO now, I'd probably say that's firmly in the negative phase as well, though there is a chance that that could tilt a little bit more towards neutral than it currently is. Now, in previous years for these way too early prediction, I have only made these predictions via long range statistical analysis. I will still adjust the analog years using said statistical analysis, though, and I will also use general trends based on previous seasons when appropriate. And then snow prior to the 1970s have been adjusted to a 4.3-inch average per winter on analogs, and all forecasts will cover what has happened in 1 out of 3 winters and at the Portland airport. So what that essentially means is if I was purely guessing, I should expect to get about 1 out of every 3 forecast parameters correct. And then anything crossed out, I will return during both my October and my December forecasts. Then also what is new for these upcoming winter forecasts. Analog years, I am now including all the way back to the start of the downtown Portland data set in 1871 to 72, thanks to reconstructed ENSO ONI indexes. Previously, I stopped at 1900 because that was the furthest back that I could previously reliable see an ENSO reconstruction data set. Now, some ENSO years, especially in that early to mid 1900s time period, have been adjusted for my analog classifications in light of these newer data sets. So, like as an example, a previously ENSO neutral year may now be a weak La Nina year because these new data sets suggest, oh, actually, these were possibly even closer to a moderate La Nina. Again, just using that as an example. I'm also going to take a look at what's called the quasi-biannual index or quasi-biannual oscillation, depending on the language you use. I do need more time to see the interactions and specifically how it affects our climate. And if I deem it necessary, I will start to include that this October, but that is not a guarantee. So, on to why I'm so confident that we will be seeing a change from El Nino to La Nina, and we first have to look at the climate models. All the NOAA suite of models, both the in-house ones and the global models they use, are showing pretty good confidence that we will be going into a La Nina even by early fall and late summer for the most extreme models. And the CFS model is showing even further correlation towards a moderate or strong La Nina versus the NOAA model, which is models which are showing just a weak to a moderate La Nina at this time. So that's just one look. Looking at the Australian look, and they currently only go out to August for their forecast, but still gives a pretty good gauge in that we're probably quickly going to transition into a La Nina like conditions according to their suite of models that they use, with the only one still in a positive anomaly by August being Mateo, France, which is still in the ENSO neutral category. It is not anywhere close to El Nino. Now, the Australian method does use a single month average compared to the NOAA method, which uses a 3-month average instead. So, just FYI with that. But even without looking at these climate models, I could take a look at just the sea surface temperatures, both at the surface and down below, and see what's happening, and then conclude that, hey, a La Nina looks pretty likely. So looking at the average sea surface temperature anomalies during the main 4 weeks of March shows generally above normal conditions persisting throughout the tropical Pacific. But when you're looking in closer and looking at the temperatures further down, the progression between early February and mid-March showed a cold pool developing and bubbling up closer to the surface. In early March, the warm pool, especially in that central eastern Pacific, right around 120 degrees west, was showing about 50 meters deep of warmer than average water of about 2 to 4 degrees Celsius. Now, when you get closer to today, that warm pool has almost completely disintegrated, and now it's not really shown here, but if you look at a current sea surface temperature anomaly map, it's it still shows above average, but it is very small, and there are some below average anomalies starting to pop up at the surface, signifying that this colder than normal temperature is starting to bubble up to the surface. And on top of that, trade winds have started to re-increase, signifying that upwelling is starting to occur in greater frequency compared to this past winter. Some of this colder than normal temperature gets up to 6 degrees Celsius below normal, which is significant at any time. So that's, if that were to hold, that would be a pretty significant La Nina. But there's still a good 7 to 9 months before we can firmly know what's happening for the upcoming winter. So we'll see what happens in our October forecast. Now, one thing to note is that a major windstorm becomes less likely the further you go into either La Nina or El Nino. So if it gets to a moderate or a strong La Nina, I do not anticipate a major windstorm to occur when it comes to wind gust. But something like what occurred this past winter, where the wind gusts are relatively moderate in the upper 40s, but the ground is frozen and the temperatures are low, that makes the trees more brittle and far easier for power outages to occur as a result. So just keep an eye out for that. Now, onto our analog years. I am probably going to add more when it comes to October. I decided that these 15 were a good starting point because these 15 analog years were the 15 years that came from a moderate or a strong El Nino transitioning into a La Nina of any strength. So this was a really good starting point. So let's just find out what happened during these 15 years. Oh, also as a side note, my top analog years for October and December will probably be some combination of these 15 years and not of any of the years that I add in October, where I will just use that for my general analog predictions just to keep me honest and not overweight the top analog years for stuff like the water year rainfall. So using these 15 years alone shows that we're looking like we're going to be above average. Only 3 of the 15 analog years are showing anywhere below the long-term average of 37 inches and below long-term median of 35 for that matter. And the overall median is at 44.73 inches. This gives me pretty good confidence that we will be above average. On top of that, 4 of the years qualify as what I like to call a hyperactive year, which I define as a top 10% of all the years Portland has experienced, which that threshold gets crossed right at about 47 inches of rainfall. One year also just barely misses out by 600ths of an inch of being classified as hyperactive. So I would not be surprised if we see a lot of rainfall this upcoming winter. Looking at the temperature departure from average, this is trend adjusted to each decade. So it looks like, based on these 15 analog years, that an extreme winter either way does not appear that likely, but a tilt towards below normal temperatures is favored. Only 2 winters were anywhere above 300ths of a degree above their decade averages, and conversely, only 3 of the analog years was more than a degree and a half below average. The biggest concentration was between that right at the long-term average, or right at their decade average, to about a degree and a half below average. So that's where I would be most confident making my predictions. The median is about 6,500ths of a degree below average. The lowest winter temperature, I am also adjusting this to account for climate trends. And it shows that there is a lot of years where it has a low temperature at some point during the winter between 10 and 14 degrees. In fact, most of the years occur this. Only one is above the long-term median of 20 degrees at 29 degrees. That was actually one of the warmest winters when it came to the lowest wintertime temperatures. And 2 did get into the single digits after adjusting for climate trends. The median overall is 13 degrees. And lastly, the one most people care about here is the adjusted snowfall forecast. So the median here is 3.6 inches. However, this really occurred in 2 clusters. One cluster was really between 1 and 4 inches, with the median year being this last year here, before we go into our upper cluster, which really was between 7 and 12 inches, with a few isolated it further up at about 17 inches in the earlier analog years, and a singular year with no snow that occurred during the snow drought in the mid 1970s, where seemingly despite any atmospheric conditions, Portland did not want to see any snowfall at all. So now on to our statistics that we have used previously. So there has been 9 consecutive winters with measurable snowfall at the Portland airport. This is a record high. Chance of a 10th occurring unadjusted is about 3%. This is, however, overwritten by La Niñas almost always having snowfall, like as you can see with the analog years. 14 out of 15 of those analogs had snowfall. And when you look at La Niñas in general, every single week and moderate La Niña in my data sets have had measurable snowfall at some point during the wintertime. And for strong La Niñas, only 3 didn't have snowfall, but they did have the correct pattern for snow at some point during the wintertime. But precipitation never really materialized for measurable snowfall. That didn't always occur with ENSO neutral years or El Nino years of any strength. Only 3 winters have produced a temperature under 20 degrees with less than an inch and a half of snow. All have with 0 inches. And I am keeping this statistic in here because with the likelihood of it getting into the teens. Next winter, it's pretty likely we'll see snow in probably more than an inch and a half of snow, at least at the Portland airport. And then also, just to add statistics to that lowest winter temperature, all but one of the 15 moderate or strong El Nino to La Nina years produce an Arctic blast at least some sort of intensity. Now, what I consider an Arctic blast is when it meets one of the following criteria: either coldest high temperature of 26 degrees or colder, a coldest low temperature of 14 degrees or colder, or a coldest 850 millibar temperature of 12 degrees Celsius below zero. Now, that is a 93.3% occurrence rate, which is very high considering the general occurrence rate for an Arctic blast on any given winter is closer to about 35%. Then also, all but one of the 15 moderate or strong El Nino to La Nina years had the La Nina water year be wetter than the El Nino water year, also 93.3% occurrence rate. As of April 1st, Portland was at 119% of normal for the water year, which is projected to be about 44.2 inches if the pace is held. So we'll see what happens in the upcoming months if that's what actually occurs. But that does increase the confidence that a hyperactive water year is at least possible. And with temperatures being either at or a little bit below average, that's also good news for mountain snowfall. So, what are my way too early predictions for upcoming winter? And as a disclaimer, I am not including all the predictions, parameters at least. So let's go on to the basics. Rainfall. Possible hyperactive water year. I'm expecting it to be in the top third for all the years Portland has experienced, which signifies about 41 inches or more. So wintertime, I'm anticipating about 16 inches or more. Now, that means if you're translating it to the rest of the Willamette Valley, that's about 117% or more of the long-term median, or about 125% of the, 110% of the long-term average. Temperature differential below normal temperatures favored, though I don't anticipate an extremely cold winter, up to 3 degrees below average. Windstorms, while it is still too early to call, I don't expect a massive windstorm if it gets into the moderate La Nina category or stronger. The question is whether it's just going to be an average windstorm year or a tame year if it gets into that moderate category or stronger. Lowest temperature, I am anticipating below 20 degrees with a highly enhanced chance of an Arctic blast. The most likely to be active time, it is way too early to call because I rely on top analog gears to make that call versus all these other predictions where I can at least kind of make a guess with the all analog medians, but prefer top analogs to make a little bit more fine tuning to said predictions. Now onto our snowfall predictions. Mountain snowed up on April 1st, greater than 130% of normal. I am also anticipating it is going to be potentially hyperactive because especially a lot of the precipitation in the Willamette Valley will end up being snow at the mountain, especially with it being at or a little bit below average. Probably going to get more snow overall. So I don't anticipate the upper chairlifts at both Meadows, Timberline, and Bachelor to be open that often until the springtime of 2025 next year because of how much snowfall I'm anticipating. And then for valley snowfall, I do think that there will be some sort of snowfall, but that depends on the strength of the La Nina. If it is a strong La Nina, I do anticipate it's going to be closer to the 1 to 5 inch category. But if it is a moderate or a weak La Nina, I'm anticipating anywhere from about 4 to 12 inches. That's the biggest cluster that I could see, was that the 1 to 4 inch category is more towards the stronger La Ninas, and the 4 to 12 inches was more towards the moderate or the weak La Nina categories. So that is where that prediction comes from. So that is it for my long range prediction. if the last 3 summers are anything to go by, I guess we're going to have some sort of big heat wave that's going to warrant a more forecast videos in the summer. So if that happens, please be on the lookout for that. Otherwise, the latest I will see you all is going to be next October for the long range winter weather prediction. So until then, please stay safe out there and take care.